Today I'll be using the constructivist method to tutor a student on equivalent fractions. Now, in constructivism, we're able to use mathematics in a very real life way so that students will be able to learn through visual formats while making models to help demonstrate their mathematical knowledge. Now, I have been tutoring the student, so I know that they are able to show equivalent fractions using fraction tiles. So if I ask the student to show me a fraction that is equal to 1/2, they could click the 1/2 tile and then match up fractions to show that they are equal. So let's say they wanted to try thirds. Well, they would realize that 2/3 is not going to be equal to 1/2, that they're not going to be able to do that. So maybe they'll come down here to 1/4, and they're going to show how we can make fourths be equal to 1/2. So the student will click and drag the tiles, and I'll ask them, okay, are 2/4 equal to 1/2? Using this visual, they would tell me that yes, 2/4 is equal to 1/2. Next, I would ask them, why do they know that? How do you know that 1/2 is equal to 2/4? And they've explained to me, well, I see that 1/2 of a fraction tile takes up this much space. When I click and drag 1/4 and then another fourth, I could see that these 2/4 are indeed equal to 1/2. And then because I know they have learned this before, I would ask them to show me with an equation. So they could write 1/2 is equal to 2/4. Now next I'm going to ask them, if we didn't have the fraction tiles, how could we know that 1/2 is indeed equal to 2/4? Now they could do this in a couple of different ways. One way I could ask them would be, let's say you have a pizza. Show me how you would have a pizza in half. You would draw the line in half. Now let's say I wanted there to be 4 pieces of pizza because you have 4 friends who want to eat it. You could draw a line across and show me that now we have 4 equal pieces of pizza. Next, I would ask them, how could we show it without a picture? So how can I get this 1 to become 2 and this 2 to become 4 using your knowledge of multiplication? Now here's where the student will have to apply previous knowledge of multiplication to get 1 to become a 2 and a 2 to become a 4. The student will tell me, well, I know if I multiply 1 times 2, it will become 2. If I want this 2 to become a 4 using my multiplication skills, well, I know that 2 times 2 will make 4. Now I will ask the student if they notice a pattern. And they're going to tell me, well, I know that when I multiplied the top number by 2, my numerator, it became a 2. When I multiplied this denominator times that same number times 2, it became a 4. And I'm going to tell them that is the rule of making equivalent fractions. Whatever you do to the numerator, you must also do to the denominator. So now I'll give them another fraction. I'll give them 1/3. And I'll tell them to make any equivalent fraction that they want. And they might say, well, how would I do that? And I'm going to refer them to the previous example and say, well, I see what you did here. Can you do the same thing? So pick any number you want and multiply it times the top. So let's say they pick 3. They're going to multiply the 1 by 3 and this 3 by 3. And now they'll have 3/9, which is equal to 1/3. And there we have equivalent fractions.